Welcome to this tutorial on creating sequences with np.logspace. In this video, you'll learn how to generate logarithmically spaced arrays in NumPy, a powerful technique used in scientific computing and data analysis. NumPy.logspace is a function that generates arrays with numbers spaced evenly on a logarithmic scale. Unlike linear spacing, where values increase by a constant amount, logarithmic spacing increases by constant multipliers. This makes it extremely useful for scientific and engineering tasks that work in orders of magnitude, such as analyzing frequencies, pH levels, or exponential growth patterns. The basic syntax for logspace is np.logspace with 4 main parameters. It takes start, stop, num equals 50, and base equals 10.0. The start and stop parameters define the range of exponents. Num specifies how many values to generate with a default of 50, and base sets the logarithm base with a default of 10. Let's break down the key parameters. Start is the exponent for the starting value, calculated as base raised to the power of start. Stop is the exponent for the ending value, calculated as base raised to the power of stop. Num determines the number of samples to generate, defaulting to 50 if not specified. Base is the base of the logarithm, which defaults to 10.0 but can be changed to any positive number. Here's a simple example. We import numpy as np, then create an array using np.logspace with start 0, stop 3, and 4 samples. When we print this array, we get 1, 10, 100, and 1000. Notice how each value is 10 times the previous one, demonstrating the logarithmic spacing with base 10. You can use different bases for logarithmic spacing. In this example, we use np.logspace with start 1, stop 4, 4 samples, and base equals 2. This generates powers of 2, 2, 4, 8, and 16. The base parameter gives you flexibility to work with any logarithmic scale you need. It's important to understand the difference between logspace and linspace. Linspace from 1 to 100 with 4 values gives you 1, 34, 67, and 100, evenly spaced in a linear manner. Logspace from 0 to 2 with 4 values gives you 1, 4.64, 21.54, and 100, spaced logarithmically. Logspace provides more granularity at smaller values, which is crucial for many scientific applications. Logspace has several common use cases. It's widely used in scientific computing when working with orders of magnitude. It's essential for creating logarithmic scales in data visualization, particularly for plots with wide value ranges. Signal processing and frequency analysis heavily rely on logarithmic spacing. It's also perfect for modeling pH scales and exponential growth patterns in chemistry and biology. Understanding logspace will significantly enhance your ability to work with scientific data in NumPy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.